So as you can see, this is an ESP8266. So it has Wi-Fi capability. So this just pings an API server. Kind of go over the overall architecture in a bit, but yep. So this is that, and it's just using some of the cables to connect to our BME280 sensor. And yeah, I just put it in a plastic box just because it's pretty easy to carry around. This right here is the home server. So this is the one that is connected to the Wi-Fi. All right, so this is just going to be a little bit of a architecture overview. So we first start off with the ESP8266. So this is equipped with the BME280 temperature sensor. And what this does is that this communicates over the Wi-Fi, right? So this is over Wi-Fi with basically our home server. So this here interacts. There we go. Yep. So this here interacts with this over Wi-Fi. So it interacts with the REST API, which is in Spring. It's written in Java, and then this stores everything in a PostgreSQL database, which is Dockerized. And basically, what happens is that this sends it every second. So per second, it sends a kind of a data point, which includes the temperature, pressure, and the humidity, right? So it sends all this data every second to the Spring API, or roughly every second. And basically what happens is that the Spring API takes this in and puts it in the database, and the cron job effectively calls on the database to take all this information and compress it, right? So basically aggregate the data. So because let's say if you were to get the temperature readings for 1 hour, right? This would be 60 points per minute, right? Because every second one, and 60 minutes in an hour, right? So it's 3,600 points just for 1 hour. So that is obviously quite a lot of points, and you might not need all of those points, right? So that's why we do aggregate data as well. So we do it per minute. So every minute it gets run, and it basically compresses 1 minute of data into one singular point. And then it also does the same thing for hours. So it takes all the minute points and then aggregates that into an hour. And we are also going to in the future do that for days, right? So this would basically allow for us to easily fetch information without not fetching way too much information, right? Like the granularity level is variable. And the last part of it is a Next.js client, which also talks with the Spring API right here, and it just fetches a data based on the time period. So now I want to show you guys the API. So let me just refresh. So you can see here it's a Next.js and it's deployed right now. It's not secure. I'm gonna add SSL support later, and the reason is because the sensor, like the ESP8266, is using an HTTP protocol. So I just want to make sure that it when I upgrade it to HTTPS, it still works. So yeah, I just haven't gotten around to that. That's why. But yeah, you can see it fetches the current temperature, humidity, and pressure, and also fetches aggregate information. So it plots that out on this nice, and I'm using rechart.js, I believe that's the library name. So just using rechart and an area chart to plot all of this out. So you can see it was coldest around 7 a.m. and then it has gotten better and better, and now it's positive. So let's go back. So this is yesterday, Saturday. You can see all the information. Let's go to maybe, let's say Thursday. Yeah, Thursday looks like a good day. So here, if we go, because it's pretty even, so it's very easy to tell. And now, if we go to minute, you will see that now we're getting information by the minute. So you can scrub through and see all of this information by the minute, right? So obviously it's going to be more messy as compared to an hour because it's aggregating, right? But you can see that it is still like a very interesting visualization. And you can also select the date. So let's say I want to go to, I think the 21st was really cold. Maybe not. The 22nd, 20th? Yeah, 20th was pretty cold. You can see it got down to negative 13 almost. Yep, negative 13. So yeah, so that has been the demo for the weather station.